Alright, it's Toby again, and I am still working on PLC next. Alright, so what I've done is create a multiplexer as a function, and I want to use that in my IO processing. So I built this multiplexer. It's getting upset with me because I drag it back over. Anyway, I wanted to click on it first, that way you guys can see what the variables are, inputs and outputs, and then the code is the same as what we did over here. Well, except for that else. So I'm gonna go back and let's see, do some safer code, and then end if you don't end the if, it gets upset. And there we go. Okay, so if I rebuild that and make sure it's okay, it should tell me that we're not using the multiplexer anywhere. 0, 1, 0, blah, blah, blah. Okay, cool. So if we come back over here to multiplexer and drag this puppy in here, then insert element. We want a power rail. We want a contact. And then we could do 2. And I'm surprised that we can't like drag and drop, but oh well. And then we can use these guys because that's the input for IO processing, which is here. And then copy and paste all the way down. So yeah, that didn't work out well, but I was still in the same rung. So we will do insert element, give it a power rail, put that in there, and we want input 1. Connect that. If I want to drag this over and make it look pretty, then you can. And essentially what we can do is fill in the rest of these, make it look like a card. So stand by. Alright, so I got the rest of these in here, but you can see that they're red, so they don't exist. So we got to create them. And you can do that by creating a new variable, call it external. Create a new variable, external. And the red goes away. And if we come over here, then we should see that in our IO processing, which we do. Note they come in at the order that you put them in, which that could be a pain in the rear later, but only at the PLC level when you're transferring it, or in your HMI web server, because it will transfer into node red out of order. Or probably, I say probably because I haven't got there yet, whatever, how do you call it, application that you're looking to, how should you say, interface with. Anyway, I'm going to delete these extra multiplexers because I'm only using one. And as you can see, there was a multiplexer 1, multiplexer, and it's local. So if I come back over here, I got a PLC out, and we can insert a coil, and we also have to insert a power rail. From my understanding, this is kind of like Siemens. Everything goes red. It doesn't like the CO1. We're going to change it to that output 0. And so in this case, we're going to multiplex. Well, we're going to take all the inputs in, but we're only multiplexing the first 3, so really I didn't have to do that, but I have it set up over here anyway. I can create a different output for that multiplex part if I wanted to bring 3, 4, or 4, 5, and 6, and 7 together. So why is it upset now? Let's see what the messages are. Well, it thinks that it's multiplexer 4, but we only have 1, so let's change that. I should clear that up. And right now it's not going to do anything but input 4, 5, 6, or 7, or it shouldn't. And we're going to change the output so that we're not interfering with that one. We'll call this output 1. Alright. Create a new variable. We'll call it external. So from here, there's nothing more that we're going to do there, but I want to, if I want to turn on an actual PLC point, gotta rebuild this. And then if you look underneath here, multiplexer showed up there, showing it's a function of IO processing. And if I come up and look at the data list, there's output 0. And if we follow output 0, she's got an HMI tag, but she's also associated with the output 0. So if I do output 1, and I come over here, it says I can select the process data item. And if I want to see it on node red, I also have to create a variable for it. So I'm going to add the HMI tag, and then I am going to double click on that, and I'm going to pick output 1. So now it is physically attached, or it's attached. It's not physically attached. It is signally. The signals will go to the physical output, and it will show up on the HMI. But in order to do that, let's go check it. So if I'm over here on the HMI server, I got output 1, and it showed up automatically because I made an output, or I made a HMI tag. So what if I want the rest of those inputs to show up? Well, as you can see, they're not on the data list for the HMI server, so they're not going to show up. And we're just going to leave it like that for right now because I don't feel like playing with it because it's my lunchtime and I'm bored with the day job, so playing with this. Alright, so I'm going to turn off all my IO. I've compiled. I don't have any messages. We're going to write and start project. It makes you log on. And there we go. So if I turn on, you can see I'm turning on my IO. And so if I turn on 3 of them, it's doing output 1. So right now, we are just going through the multiplexer. And if you want to see that real time, really. And so that's what we have, right? So let's go over to node red and see what we got. And you know, this is a little mismatch on my part, but essentially I would get rid of this code and just use the multiplexer so that I could repeat that, or turn it into some kind of, you know, like a alarm monitoring so that you can see what the IOs are, and not necessarily put it to an output, but you can put it to an output. So you could say, you know, this card is full or something, so that the guys know where their spares are or something. I don't know. I'm just trying to be creative. All right, so if we go over to Node-RED, I don't want to restore pages. You guys might see all stuff that you don't need to see. And if we pull this, well, it's going to do that. So 192, 168, we want the 51, 80, 80, and I'm on a 1 in 10. So I should be able to pull it up. This is where my flow was the other day. And what I had done was I was trying to look at PLC read variables to understand if it was actually a split for the, like kind of reverse engineer it, because what I wanted to be able to do is look at the difference between, so this is array 4, so this is my debug 4, so right now I just have three inputs on, so my output is not on. My fourth input is not on, and if you look at what I got here, I'm just looking at the 4 inputs. And so this is using some JSON to change the payload so that I can assign the message payload to a register, and so that we might see it and then break it out. What does that look like compared to the way it comes out of PLC read? Right now we're going to have debug 2 and debug 4 on. So if I clear that out and we look, so right now I can see straight away, I've got 3 inputs on and my 4th input is off. If I go in here, it matches that. But what I did is I just pulled that value out, and that's what the function block will get you. And then this is the format that you're looking for, the message dot payload, and because you have an array, whatever dot value, which those of you that are familiar with JSON and C and stuff like that, this is the object-oriented stuff going on, right? So those of you that are not familiar with that, the way that you can break it down is with your debugs, because you know exactly what's coming out of PLC read variables, because it tells you this is your message object, the payload object format. And they call it variables in whatever code's behind the scenes here. But what I wanted to see is, so output 1 comes now, and then this is the ones that we were looking at before, IO processing 2 and processing 3, it comes up. This is from a different project or a different program. Anyway, so this output 1 should be on. So now that I've checked that and I trigger it again, we should see, and let's delete all and do it again so that we can get a full view. And you see my array goes to 7. So my 5th object is output 0. My 6th object is, it's the 7th object because we're starting at 0. Output 1, which is true. So if I wanted to do that, then I could say output 1 equals message dot payload, and this is basic for most people. Let's do that. And so we want to look at object 6, and we just want to pull the value. And then if we really want to see it, then we will say output 1. Done. Deploy. So let's go again. And there we go. True, true, false, true. So that matches up because input 3 is off. So if I turn on input 3, which is my 4th one physically, and we go again, then we all go true. I'm going to turn the first three off. Now, if I turn the first three off, what do we expect? We expect false, 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 true, and then false. So here we go. False, 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 true, and then false. So anyway, this is where I'm going. This is an example of a Node-RED function, how you pull the payload out. And it gets more complicated when you start looking at different types of arrays. You can also do this with strings. And I'm also splitting it. And that's breaking out my objects. So I'm pulling these objects here and making them individual messages. And I didn't think that I had to do that, but if I take this out, then the function doesn't work. So it's not meeting however the formatters that's coming out of PLC read variables. So something to keep in mind. And what I'm trying to do is get to a point where I can use these individually so that you can see them on a page for visually see them on the HMI screen, or what do we call it, the dashboard screen. So anyway, that's what I'm trying to do. All right, thanks.